Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alright, so continue to the next subtopic, polynomial regression under curve fitting method. So learning outcomes for the polynomial regression. The first one is to derive the constants of a polynomial regression model based on this squares method criterion, and then use an examples to derive formulas for the constants of a polynomial regression model. Then analyze, identify, formulate, and solve several engineering problems using the polynomial regression analysis. So under polynomial regressions, what you need to know, okay, for the linear regression, okay, now we can see the difference between each regression. Linear regression, okay, so you have y equal to a naught plus a1x. Multiple regression, okay, so you have y equal to a naught plus a1x plus a2x, okay, plus dot dot dot. Okay, for polynomial regression, so you have y equal to a naught plus a1x plus a2x square. That's why we call it as a polynomial. Right? The least squares procedure can be readily extended to fit the data to a higher order polynomial. For example, suppose that we fit a second order polynomial or quadratic. That's why you have x squared. Right? For this case, the sum of squares of the residual, okay, just like before. Okay, so it depends at this value. Right? So only the difference at this value. For linear, you use this one. For multiple regression, you use this one. Okay? And then following the procedure of the previous, okay, derivation. Okay, based on this, you derive based on by respect to each of unknown. Start with a naught. Okay, this one is a naught, and then right, and then a1 and a2. And lastly, you will get the new equations or the new matrix forms, which is okay, n times a naught plus summation xi times a1 plus summation xi squared times a2. So we take out and put it in matrix forms, so easy to see. So summation summation xi squared, summation xi, summation xi squared, summation xi cubed, okay, summation xi squared, summation xi cubed, summation xi power of 4. Right, so times a1, a naught, a1 and a2 equal to summation y, summation xi yi, summation xi squared yi. Okay, so please look at the appendix, under for your past year questions, either the question is given or not. Okay, if not, please remember it, memorize it. If you have in your appendix, so just straight away. Okay, right. So you will have this one, a naught plus a1x plus a2x squared plus dot 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 until an xn. So m's order polynomial. So depends on m's order polynomial. Right? So we have x power of 3, x power of 4, x power of 5, depends on the m's order polynomial. And then for the standard error, how to calculate for the standard error? The same example like before. Okay, same example like multiple regression. Okay, so syx sr over n minus n plus 1. Okay. Okay, so straight away to the example, right? Based on the first example in your okay, so you will have x and y. Okay, normally you all only given the value of x and also the y. Okay, So you have xi, yi, so 0, 1, 2, 3, 4, 5, 6. And then you have yi, 2.1, 7.7, 13.6, 27.2, 40.9, and also 61.1. So, okay. So what we need, okay, so we need the value of n, and then summation x square, okay, summation x cube, and summation x power of n. Okay, and then you get a1, sorry, a0, a1, a2. Then you need summation y, summation xy, and summation x squared. Okay, so from the term given, okay, so you have the value of x. So x 0, 1, 2, 3, 4, 5. Okay, and summation. And then you have value of y 2.1, 7.7, 13.6, 27.2, 40.9, and also 61.1. Okay. So the summation of y, you will get the total up all the values. Okay, and you will have 152.6. Okay, so now we want the value of n. So what is the value of n? So you calculate, you have 0, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So your n is equal to 6. So you replace. Okay, so you replace n with 6. Okay, and then summation x. Summation x, we have 0 plus 1 plus 2 plus 3 plus 4 plus 5. So 12, 14, 15. Okay, so 15. So you replace it with 15. 15. Okay, and then summation x squared. So you need a new column of x squared. So 0, 1, 4, 9, 16, and 25. So we got the value is 55. So you replace it with 55. Okay, and then you need x cube. So x cube, so 0, 1, 2 power of 3, so 8. Okay, and then 27, 64, and 1, 2, 5. So total out you will get 2, 2, 5. So you replace it here, 2, 2, 5, 2, 2, 5. And then you need x power of 4. So you calculate x power of 4. Okay, 0 power of 4, 0, 1 power of 4, 1, 2 power of 4, 60. So you calculate, and then you get the sum of summation for x power of 4. So you will get 9, 7, 9. Okay, this one is 81. Okay, so this one is 256. So you check it back, okay? Please check it. So 125 is power of sorry, 5 power of 4, so it's 0 for 5 power of 4. And the total you get 979. Okay, so you substitute 979. Okay, next you need the summation y. So summation y already have 152.6. Then you need to x times y. So 0, 7.7, 13.6 times 2, so what's the value? And then 37.2 times 3, so what's the value? 4 times 4, 2.9, then 5 times 61.1. So we got the values is, so total up is 585.6. And another one is x2 square times so x square, you take at this Okay, so 0 times 2.1, 1 times 7.7, 4 times 13.3, and so on. So please calculate. Okay, so we get the value of 9, 7, sorry, 2, 4, 8, 1, 8. Okay, so once you got all the values, so you substitute 2.6, 5, 8, 5.6, and 2, 4, 8, 8.8. Okay, okay. So what you need to do now, rewrite it back in a place in a proper way. Okay, so write back 6, 15, 55, 15, 55, 55, 55, 55, 979. A1, A2, 152.6, 585.6, and 2488.8. So at this stage, okay, in order to calculate the value of A0, A1, and A2, same method with the multiple regression. At this stage, you have, okay, you need to back to the topic 2. So you need to use either naive cross elimination method or cross Jordan method or LUD composition. Okay, so up to you in order to get the value of A0, A1, and also the A2. Okay, then calculate for the standard deviation and the coefficients. Right? So please state the value of A0, A1, and A2 in the Google form that I will attach together with the link, okay, in the group. Okay? Right, that's all from me. Thank you very much. See you again. Assalamualaikum warahmatullahi wabarakatuh.